Welcome to the DIY Honda Garage channel. The DTC P0192 indicates a low voltage condition in the fuel rail pressure sensor circuit. This error specifically points to the fuel rail pressure sensor FRPS, which plays a crucial role in engine performance by monitoring the fuel pressure within the fuel rail. Its appropriate functioning is vital for the powertrain control module PCM to manage fuel delivery accurately. Located typically near the fuel rail, the FRPS is connected to the PCM and relays information that helps maintain optimal fuel pressure. When the DTC is triggered, it suggests that the sensor is receiving a voltage below the expected 0.31 volts, which can hinder the engine's performance and efficiency. The diagnostic process involves recording freeze data, followed by systematic checks to identify the root cause of the low voltage condition. Final verification of repairs necessitates reconnecting all previously disconnected connectors to ensure that the system is restored to its original state. Once the connections are secure, the technician should exit SCS mode, signaling that the short circuit testing is complete. The next critical step is resetting the PCM using the HDS, which clears any stored codes and allows the PCM to relearn its operating conditions. Following this reset, the technician must perform the PCM idle learn procedure to help the ECM recalibrate itself after any repairs. Finally, checking for any pending or confirmed DTCs will indicate whether the repairs were successful in addressing the P0192 issue. Preventive maintenance strategies can help reduce the risk of encountering DTC P0192 in the future. Regular inspection of the fuel rail pressure sensor connectors for tightness and corrosion is crucial, as loose or corroded terminals can lead to voltage loss. Additionally, ensuring that the PCM software is updated to the latest version can enhance its performance and error recognition capabilities. Another essential practice is to monitor fuel pressure readings regularly, which can be performed during routine maintenance checks. Taking these preventive steps will not only prolong the life of the fuel pressure sensor and PCM, but also improve overall engine performance and reliability. In conclusion, diagnosing and addressing the DTC P0192 requires a comprehensive understanding of the components involved, primarily the fuel rail pressure sensor and the PCM. Each step in the systematic troubleshooting process helps pinpoint the exact location and cause of the low voltage issue, which may range from faulty wiring to defective components. By following the outlined steps meticulously, technicians can effectively restore engine performance and prevent future occurrences of this DTC. Furthermore, incorporating regular maintenance practices will ensure that connections remain secure and that systems operate efficiently. Ultimately, attention to detail in both diagnosis and preventive care is key to ensuring the longevity of your Honda Accord's performance. The fuel rail pressure sensor is integral for measuring the fuel pressure within the fuel rail, providing vital data to the PCM for the fuel injection process. It operates by converting the pressure signal into a corresponding electrical signal, which should typically exceed 0.31 volts. When the DTC P0192 is detected, it indicates that the sensor signal has dropped below this threshold, which may lead to suboptimal fuel delivery. This situation can arise from component failure, wiring issues, or a defective PCM. The FRPS usually sits on the fuel rail, accessible for monitoring and replacement. Performing a thorough inspection of this component and its connections is essential for diagnosing the cause of the low voltage indicated by the DTC. Several potential causes can lead to the P0192 DTC being triggered. First, a short in the wiring can create a circuit that does not allow adequate voltage to reach the sensor. An open circuit can occur if there is a break in the wire leading to the sensor, preventing any voltage from being transmitted. Furthermore, a defective fuel pressure sensor itself could fail, causing it to output a significantly lower voltage than expected. Lastly, issues within the PCM may hinder its ability to process signals correctly, potentially leading to inaccurate readings from the FRPS. Each of these possibilities must be thoroughly checked, as they could prevent the engine from reaching operational efficiency. When the P0192 DTC is present, there are several symptoms drivers may experience. One of the most noticeable indicators is the illumination of the check engine light on the dashboard, which serves as a warning that the PCM has detected a fault. Additionally, drivers may notice poor engine performance, which could manifest as rough idling, stalling, or sluggish acceleration due to inappropriate fuel delivery. Moreover, issues with the fuel delivery system might surface as the ECU struggles to maintain the right fuel pressure for optimal combustion. Recognizing these symptoms early can aid in avoiding more significant engine issues down the line. The first troubleshooting step involves turning the ignition to the on position, either by turning the key or pressing the engine start-stop button. This action powers the vehicle's electrical systems without starting the engine. After this, the Honda Diagnostic System, HDS, should be used to check the current fuel pressure signal values sent from the FRPS to the PCM. If the voltage is below 0.31 volts, it confirms that the low voltage issue is replicated. If the values match this condition, it indicates a consistent fault in the system, prompting the technician to proceed to the next troubleshooting step. If the values exceed this threshold, it suggests an intermittent problem that may require further inspection of wiring and connections. In the second troubleshooting step, the technician must first turn the ignition to the lock position, which powers down the system. Following this, the fuel rail pressure sensor 3P connector needs to be disconnected. This step is crucial to isolate the sensor from the circuit so that accurate readings can be taken without interference from other components. After disconnecting, the ignition should again be turned to the on position, and the HDS must be utilized to check the fuel pressure signal. If the voltage still reads less than 0.31 volts, it indicates that the problem persists, and the technician should move on to the next step to further diagnose potential causes. If the values differ, further examination of sensor connections and terminals is required. The third step in the troubleshooting process starts with the ignition turned to the lock position. The next action is to jump the SCS line using the HDS, which puts the diagnostic system in short-circuit testing mode. Following this, the PCM connector must be disconnected to ensure that tests are accurately measuring the sensor's connectivity. The technician should then check for continuity between the designated test points to assess if there is a short in the PF power feed wire. If continuity is found, it signifies that a short exists in the wiring between the PCM and the FRPS. The technician would then need to repair this wiring to restore proper function. If continuity is not present, it would indicate that the PF wire is in good condition, and further steps regarding the PCM may be required. In this crucial fourth step, the technician measures the voltage between two specific test points at the FRPS connector while it's disconnected. This measurement should be taken while the ignition is turned to on mode, which energizes the electrical systems required for testing. The expectation here is to see a voltage measurement close to 5.0 volts. If this voltage is present, it points to a functioning VCC1 voltage supply line and confirms that the fuel rail pressure sensor is defective and needs replacement. If the voltage reading is absent or significantly lower, it indicates a different route needs to be taken. To find the root cause of the low voltage condition, likely pointing to issues in the wiring or PCM. The fifth step starts again with the ignition turned to the lock position. Similar to previous checks, the SCS line should be jumped using the HDS to enable short circuit testing. Afterward, the PCM connector must also be disconnected to ensure that the readings will be reflective only of the sensor wiring. The technician must check for continuity specifically within the VCC1 line, which supplies voltage to the FRPS. If continuity is verified, it means there are no breaks in the wiring, and further investigation into the PCM or its software should be performed. However, if continuity is absent, it signifies an open circuit in the VCC1 wire between the PCM and FRPS, necessitating repairs to restore the connection. Please like and subscribe to the channel. See you next time.